here this truth table shows that if the top one zero placement has 0 and bottom one's zero placement has 0, the sum should be 0. And there should be no carry as well. And if A is 0 and B is 1, the sum should be 1, but there would be no carry. Same for 1 and 0. When we have 1, 1, the sum should be 0, or like the value we put on the like answer area is 0, and 1 should be carried to the next placement. So that shows in the truth table. We can actually like also understand from this diagram, like the symbol diagram. Here, like if we put actually I will show you like a simulation of this using logically. So yeah, it will be more clear than me just saying it. Okay, here like you can see that truth table matches with what we want when we're adding just binary numbers. That's what we need to know for now. Okay, let's move on to this full ladder. So full ladder represents uh, like placements after zero placement. So that after zero placement, any placement could have a carry from the previous set. So here, this top number, the let's take the first like the 1 and 0 in the first part as the zero placement, then first placement, and the second placement, we have a carry in from the second placement. So when we need to add these numbers, three numbers in the third placement, we need to use the full ladder. Okay, so here, let's actually take the truth table value of the moment we have at the uh, second placement. Second placement. Okay, so here, so carry in is 1, A is 1, B is 0. So let's say see the equivalent in that here A is 1, yeah, carry is 1, B is 0. That is the third one from the bottom in the truth table. So here the sum is 1, okay, but there's a carry out. So uh, as you can see in the like the answer section for the 110 addition, uh, the 0 is left in the answer and the 1 is carried. So yeah, that's what the truth table also gives us. So it adds the numbers as we want. You can try and like add yourself in these combinations in the truth table. And finally, we are moving on to the 4D binary addition circuit. Also, like ignore any like outdoor sounds that's coming. It's just yeah, it's unavoidable, unfortunately. Okay, so here, so yeah, this is to add four bit binary numbers together. So the first number we only need a half adder because there is no carry if you are just adding these two. So no problem, we can add those. And for the uh, second full ladders carry in, we are taking the carry out from the half adder, right? And for the third full ladder, we are using the carry out of the second one as the carry in, and so on for the fourth one, the same thing. And we have a final carry out from the fourth full ladder. And the sums of each placement is gotten by the uh, like the sum of each half and full ladder. So when we have we have this like there's like a kind of like example, I think. Yeah, not example actually. It's just showing inputs. But let's say like we have a number as, yeah, let's say we have one number as 000, so everything 0, and other numbers everything 1. So the let's take the first like the 0 placement. So we have 0 and 1 for the half adder. So output should be 1, and other ones also has when we take the other first placement 0 and 1, and still the out one should be 1, and the second placement we still have 0 1, and out 2 should be 1, and for the final we still have 0 1, so output should be like the carry. As you can see, the carries from the previous ones are all 0, so that doesn't matter. So the final one also, yeah, 0 plus 1 plus 0, yeah. So output should be 1, but there's also no carry out, so there's no final carry out. And like the answer we get as 1 1 1. So basically, yeah, this the first number without like, because we added 0, that we changed the output. Okay, uh, this is like matrix thing. Okay, we will look at the most of this is like going through my the things I have done, but yeah, okay. So thank you for watching this presentation. We will look at the simulations in the Logically site. Very great website, by the way, and yeah, it's very expensive, but yeah, if we are going to buy the one, but we can use the demo version just fine. But you would have to build your circuits every time. Like they have the full ladder, but others we have to build. Okay, so this is the half adder first. So 0 0, no sum, no variable. Let's take 0 1. So yeah, sum is 1, carry out is 0. Let's take 1 0. So sum is 1, carry out is still 0. 1 1, sum is 0, carry out is 1. Okay, so this half adder works just fine. Now here is the full ladder. Okay, so the 0 0 0, no problem. Let's say we have 0 0 1. Yeah, sum should be 1, 0. Yeah, actually, before I'm going to show the outputs, like how the truth table, I'm going to like explain first how this half adder works. Like, yeah, we know the truth table and we know the output, but we didn't like discuss it from the like the logic gates. So here, when we have 0 0, this XOR gets 0 and gates get a 0 from this one, and in the second one, uh, it's also 0, so this is also 0. So XOR is addition with exception to the if we have high on both in the input, but here it is all low, so this is 0, and this is multiplication, so 0 onto 0 is still 0. So that's why how we get sum and out. So let's get 0 1. So one input is 0, other is 1 in both of these cases, so this adds and we get 1 here, and because this multiplies, 1 into 0 is 0. Same story in this, the other, just the other pin has high power. So when we have both, so 1 1 XOR gives 0. If it was O, it would give 1, but this is XOR, so 0. And this is the multiplication of 1 into 1, 1. No problem. So that's how this works in the, let's move to the rest full ladder. So here also the thing is like this XOR and this AND is like a half adder. Like for the full ladder, there's basically like two half adders. The only thing more is this OR gate to add in uh, the two carry outs we get into one single one. So that's why this OR gate is used. Okay, so when we have 0 0 1, sum is 1, 0 1 0, so this one, and let's take 0 1 1. So sum is 0, it is 1. 1 0 0, sum is 1, here it is 0. uh, let's take 1 0 1, sum is 0, that is 1. 1 1 0, sum is 0, value is 1. So 1 1 1 state. So we have 1 in the sum, so in the answer section, and the other one is carried into the next placement. Yeah, so this works. Now let's look at the, yeah, it's a bit mm, like it makes my head spin, but yeah, this is the 4-bit binary adder. So we have the 0 placement numbers, first placement numbers here, second placement numbers here, the final third placement for a 4-bit adder. If we have more bits to add, then we can keep doing this. But here this is the final carry out. Okay, I made this this part to drop down, because so else this would be longer and it would be hard to see everything. Okay, so here the first sum is the 0 placement answer when we add two numbers together. Uh, so no problem. Yeah. Okay, let's take the previous example. So I added 1 1 1 and 0 0 0 in the the presentation. We're talking about the binary. So yeah, let's do that. So A not 1, A1 1, A2 1, 3 1, and the other is 0. So yeah, so the sum is also 1. Yeah, one output. The placement 1 2 1. So yeah, basically the same number if we write. So if you write it, we have to count from this side. So 1 1 1 1 1 1 1 1, and like let's add okay, let's get the decimal representation at one then add. So okay, let's say we want to add 12 and 8. So 12 and 8 is what? 12 and 8 is 20. So okay, let's first put everything to 0 0 everything. Okay, so how can we represent 12 by, so we don't need a 1 or 2, but we need a 4 and 8. So is 1 1 0 0 in the top. So this is basically 12 in decimal, and 8 in binary is 1 0 0. Yeah, uh, 1 0 0 0. Yeah, that's what we have in here. So 1 0 0 0. That's the number. Okay, so answer will be 20, right? So here this shows decimal 1, this shows decimal 2, this shows decimal 4, this shows decimal 8, this shows decimal 16. So this gives the binary number as, so yeah, 16 and 4 is lit up, so that means it's up to 20. Yeah, so it gives the answer. In binary, this can be written as 1 0 1 0 0. That's the binary answer. So if you did binary calculate addition, you would get that as the answer. So this is the the all the mm, logic and the science, the science behind this. Like this is what I actually replicated using Redstone in Minecraft. So I just learned about basic things about Redstone. Then I tried to do this. Before I could only I have done moving a block with the piston, and then actually learned a bit and tried this out. So first, obviously the first steps I did was try to recreate these gates using Redstone. Then I try to this. I explained everything about those when I was showcasing the thing I had done uh, back then. Yeah. So that's it. Thank you for listening. Have a nice day.